We will continue from what we did last week. Last week we did fall 19 test 3, spring 20 test 3, and then fall 20 test 3, all of them in logarithm and following sections in that chapter. Today we will do the trigonometric part. So let's start from fall 19. Oops, I go too far. Number 2, a sector formed by a central angle 130 degrees. So this is the sector with radius 4 centimeters. Find the perimeter of the sector. Now to find the perimeter of the sector, I need 2 parts. I need the arc length plus twice the radius, which we already know. Now then, let's do the arc length first. We have the angle in radian, in degrees. We need to change it to radian. That's 130 degrees times pi over 180 degrees. That's 13 pi over 18. So the arc length will be the central angle times the radius. It has to be in radian though, okay? The theta, when you use this formula, has to be in radian. 13 pi over 18 times 4. That will be reduced by 2, reduced by 2. That will be 26 pi over 9 centimeter. And just leave it like that. You don't need to change it into decimal. Okay, but the perimeter, therefore, is the arc length plus twice the radius. Okay, which is 26 pi over 4. What am I doing? Over 9, not 4. Over 26 pi over 9 plus 8 centimeter. Okay, now, now how about the area of the sector? The area of the sector will be 1/2 theta r squared, right? Which is 1/2. The theta is 26 pi over 9. Hold on, what am I doing? I used the S earlier. 13 pi over 18, I meant, times 4 squared. That's over 16, 13 pi times 16 over 36. I can reduce by 4, huh? Reduce by 4, this is 9, this is 4. So that's 52 pi over 9 centimeters squared. Now, you can make it decimal, but do it after you get the exact solutions. Okay, let me write it down. Get the decimal, if you really need to do that, get the decimal only after you get the exact solution. Okay, just like the one we have in number part D above here, okay? The reason I write exact solution then the approximate solution, because I actually want you to give me the approximate solution, but only get the approximate solution after you get the exact solution. Okay, after you get the exact solution. That's for number 2. That's for number 2. Let's go on. Number 3, we have done that. That's log. Number 4. Use calculator to compute. Round to 5 decimal places. So grab your calculator. Oh, cosecant. Cosecant, I cannot do it directly. So that is 1 over sine 110 degrees, right? Okay, then you use your calculator. Make sure it is in degree mode. Your calculator is in degree mode. Okay, so this test, this question here, I gave 1 point for writing it in 1 over this, 1 over sine. That's 1 point there, and then from there, the result from calculator. Let me check my mode already in degrees. So 1 over sine 110 will be 1.06418. Now then, part B, cotangent 30. Now this is in radian. No degree sign. So the angle is in radian. So make sure you change the mode in your calculator to radian. 1 over tangent 30, right? So I changed the mode on my calculator to radian. So 1 over tangent 30 is negative 0.15612. Okay. So 1 point for rewriting it using ratio or reciprocal, and 1 point to give me the correct calculated result. We did the number 5. Let's go on. Number 6. Oh, the graphing. The graphing. We have this equation y equals to -3. This is the center. This has something to do with the amplitude. This has something to do with the period. Okay. So the center is -3. The amplitude is the absolute of the coefficient of the sine or cosine. The period is 2 pi over 4 pi. Okay, so this is the yellow. This is the blue. So the period is 1/2. The phase shift, however, you need to refactor the 4 pi out from the angle. So this is -3 minus 2 sine 4 pi. You factor the 4 pi, right? X minus 1/4. You see that? Okay, 4 pi times 1/4 give you the pi, right? So the phase shift is 1/4. Okay, you shift that 1/4 unit to the right, not to the left. If it is to the left, then it will be -1/4. Okay, now how about the range? The range will be, what is the minimum? -3 minus 2, that's -5. The maximum is -3 plus 2, that's -1. The minimum is the center minus the amplitude. The maximum is the center plus the amplitude. Okay, now then the center is -3. The maximum is -1. The minimum is -5. The phase shift is 1/4. The period is 1/2. So the period will, the end of one cycle will be, the end of period will be 1/4 plus 1/2. That's 3/4. Okay, that's how we get that 3/4. We add the period, right? And then here we get the midpoint. That 4/4 divided by 2, 2/4, that's 1/2. This is 3/8. And this will be 5/8. That's the graph of sine. So we start from the middle, but it's negative sign, right? So we go down, go back to the middle, go up, go back to the middle. So the graph should look like this. And make sure you curve that. Okay, make sure you curve this. Don't do it like this. Don't do it like this. I have seen students do it this way. Like that. No. You need to show me the curve. Okay, you need to show me the curve. It won't be super accurate, but making them as like this is also a total misrepresentation of what the curve is supposed to look like. You see what I mean? Okay. So there should not be any sharps or corners. They're supposed to be curved. That's for part F. Number 7, very similar question. Number 7, very similar question. I'm sorry, I keep on jumping around. Like my screen is not good. Okay, the center is -2. The amplitude is absolute of 3, which is 3. The period is 2 pi over 2, that is pi. The phase shift, that's -2 plus 3. Cosine, factor the 2 out, that's x plus pi over 3. So the phase shift is -pi over 3. The range will be -2 minus 3, -5. -2 plus 3 is +1. The center is -2. Maximum is 1. Minimum is -5. But the phase shift is -pi over 3. When I add pi, that gives me 2 pi over 3. Okay, -pi over 3, that's the phase shift plus the period, right? That will give you 2 pi over 3. That's why I end at 2 pi over 3 here. Okay, and then from there, I do the midpoint of this. This is pi over 6. This is -pi over 12. This is 5 of pi over 12. Yeah, just do the midpoint, okay? Just do the midpoint on your scratch paper. So pi over 6 plus 2 pi over 3 divided by 2, right? You multiply the top and the bottom by 6, you will get pi plus 4 pi over 12, right? That's how we get that. You see what I mean? Now, usually this question carries 3 points. Half point for this. This is half point. Okay. The ones here, 1 point. This is half point here. 1 point here. Okay. And then 1 point for the cosine. That's positive. So it starts from the top. 1 point for the cosine and half point for the curve. Okay. In other words, if you just give me like this, like that, I penalize you half point. Okay. Is a 0 needed somewhere here? A 0, I don't ask the question about finding the 0, so not in this case, right? Yeah. In future, we'll find the x-intercepts of these functions, but that's for the future. Okay. Now, by the way, again, coming back, if you get the coordinates of this of the grids correctly, you get that 1 point, but half point off because the curve is not supposed to be like this. Okay, it's supposed to be curved. Okay, so please curve it. It's supposed to look like this. Okay, that's for number 7. Yeah, somebody asked earlier, is there any zero? Here, I didn't ask finding the zeros or finding the x-intercepts, so we don't need to do that. But I did ask this question, by the way. I did ask this question somewhere in the past. I asked find the y-intercept. Find the y-intercept. So how do we find the y-intercept? Set the function the x equals to 0. So for y-intercept, you need to show this y equals to -2 plus 3 cosine 2 pi over 3, and then show how you compute that. This is quadrant 2. 2 pi over 3 is in quadrant 2, so that's negative cosine of the reference angle pi over 3. Sorry, not negative, it's positive. Cosine pi over 3 is positive 1/2. So -2 minus 1.5, that's -3.5. Okay, am I done? If I ask you the y-intercept, is the answer -3.5? What is missing?
0.
What's 0?
The x 0.
What do you mean by x 0?
The negative, it's supposed to be 0, -3.5.
In other words, you need to write it in coordinate.
Yeah.
Okay. In other words, you need to write it in coordinate. Yeah. So so when I ask for y-intercept, you need to show me the computation, and the computation is done by write when x equals to 0, what happened to the function, and then bring it to quadrant 1, of course, adjust the plus minus sign, and then compute the value. Okay, if you have radical, let's say -2 minus radical 3 over 2, just leave it like that. Then, so write it that way first, and then you write it in decimal if you want to. But at the end, the y-intercept, when you write the y-intercept, it has to be supposed to be a coordinate. Okay. Now, in this picture here, the y-intercept is approximately here. Sorry, I need to move that a bit to the left. So it's approximately here. Of course, it's not drawn to scale, right? Yeah, it's not drawn to scale, but it's approximately there. This is when x equals to 0. Now, once in a while, I did ask that question, and somehow I thought when I asked for y-intercept, that's an extra credit because, well, y-intercept is a question we always answer anyway, right? Okay, but it turns out a lot of people don't know how to do that. It's just like, why all of a sudden this person asked y-intercept? Well, all of a sudden I just want to give you a bonus question, bonus points, but you need to earn it. Okay, and it is actually just as easy as that one. Now, x-intercept, however, is something I cannot ask yet because we need 6 point or 7, I think 7 point something. We need solving equations before we do that. I think it's 6.2. Yeah, I think it is 6.2 before we start working on that one. Okay, your test will be up to 6.1 only, which is proving. Number 8, this will not be in your test 3. Not in test 3. That's because we could not finish that graphing. Last time on Thursday, we finished only graphing for sine and cosine, but never really finished graphing for secant, cosecant, cotangent, not even tangent. But we can see the following. If we take a look on this function here, y equals to 2 minus 5 cosecant 2x. This is equals to 2 minus 5 over sine 2x, right? So the domain will be all real numbers except when sine 2x equals to 0. Is it right? But we need to solve for that sine 2x equals to 0. Again, this is actually 6.2. So I cannot really, I'm sorry, I think I'm confused a little bit. This is 6.2 or 7.2. I kind of confused that with the textbook at West LA College. Well, anyway, but sine is 0 when the angle is 0 or multiple of pi. Now, when I divide by 2, then it will be basically 0, which I don't write, plus k times multiple of pi over 2 for k an integer. Okay, so the domain will be all real numbers except when 2x equals to that, except when x equals to that. In other words, all real number except k pi over 2, where k is an integer. Okay, now how about the range? That's something we also have not seen, but I can show you this thing just to give you some feeling about this. Let's take a look on, I'm supposed to teach this on Tuesday, tomorrow. But it's not, the lesson for tomorrow, Tuesday class is not in your test anymore. So y equals to, what was the question again? Let me see. 2 minus 5 cosecant, 2 minus 5 cosecant 2x. 2 minus 5, let me make it sine 2x. Now you see that we know how to graph this already. The center is y equals to 2, the amplitude is 5, right? The center is 2, the amplitude is 5. Agree? So the maximum is 7. And the minimum is -3. Do you see that? Okay. Now from this graph, we see what is the maximum and what is the minimum of this sine function. Okay, so if I go back to my node, let me go back to my node a little bit. So the range here, so you look at 2 minus 5 sine 2x has range from -3 to 7. Is it okay? Now, let's go back to our graph. I will do the cosecant right now. Okay, so I have a new equation, y equals 2 minus 5 cosecant 2x. Now take a look on the range of the function. Notice that, you know what? Let me screenshot this so that I can pinpoint at our notes. Let me do it here, new notes. Now notice that this is 7, this is -3, okay? Now, when the sine graph gets the maximum, the cosecant graph gets the minimum. It gets the minimum. So when this bump up, this bump down. When this bump down, this bumps up. Okay, so you see that 2 minus 5 sine 2x is between -3 and 7. Now the cosecant of that, the cosecant version of that, actually has the range from -infinity up to -3. So this is the range of, I'm sorry, use different color. This is the range of the sine version, including the endpoints. Okay, now this is the range of cosecant version, including the endpoints. So you can think that the cosecant version, the range of cosecant version is the quote-unquote complement of sine version. Okay, and then from 7 to infinity. See, this is the green part, right? Including -3 and 7. Okay, this is the yellow part, including -3 and 7. So always think of it this way. If I need to find the range for secant, for example, for secant, you will look at the cosine version first. What's the range? Okay, then the secant version have the range outside of that, but you include the endpoints. Okay, now even though this is not in your test 3, but this may suddenly appear in your final or your test 4. Okay, now for sake of completeness, let's see, for example, this is a new example. Let y equals to, let's say, 4 plus 3 secant 3x plus pi. What is the range? Suppose we want to answer the range question. So at the back of your mind, you do this first. Do the cosine version, 4 plus 3 cosine 3x plus pi. What's the range? The range is, the minimum is 4 minus 3, right? The maximum is 4 plus 3. The center minus the amplitude, the center plus the amplitude. So this will be from 1 to 7. Are you with me? That's the range for the cosine version. So what is the range for sine version? On your number line, think of it. From 1 to 7 is the range. That's the y-axis. That's the range for the cosine version. Then for secant version will be everything but. Okay, so the range for the secant version will be -infinity up to 1, including the endpoints, union 7 to infinity. Okay, how about the domain? The domain will be all real numbers except when 3x plus pi equals to 0. Now let's solve that. 3x plus pi equals to 0 is when 3x equals to negative pi. Hold on. I'm sorry. I think I write it wrong. This is secant. Secant. So it's when this is pi over 2. Right? When cosine is 90 degrees plus k pi. Cosine is 0 at 90 degrees and 270 degrees. Cosine 90 degrees is 0, but we use pi over 2 for that. Okay, cosine 270 degrees is 0. That's pi over 2 plus pi. Okay, so pi over 2 plus pi, you get this, plus another pi, you get that, plus another pi, you get this, plus another pi, you get that, right? Okay, so what we need to solve is this. Subtract by pi will give me this. Divided by 3 will give me negative pi over 6 plus k pi over 3. So the domain will be all real numbers except negative pi over 6 plus k pi over 3 for all k integers. Okay, that's the little side note to find the domain and range of secant or cosecant function. Now let me go on. Number 9, compute and write the exact values. What is tangent negative 120 degrees? Make sure you show your logical steps leading to the answers. So tangent is an odd function. So this is negative tangent 120 degrees. Now 120 degrees is in quadrant 2. That's tangent is negative, reference angle 60 degrees. But tangent 60 degree is radical 3. Okay, so if it is negative angle, make it positive angle first. And then if it is not in quadrant 1, make it in quadrant 1. Then from there, you give the value. How about cotangent? That's 1 over tangent of negative 7 pi over 6. Tangent negative is negative tangent. Tangent 7 pi over 6, that's quadrant 3. So that's negative. The tangent stay the same. I mean, the negative here comes from this negative. Okay, but this is in quadrant 3. Tangent is positive, right? Tangent is positive. So I just take the reference angle without changing the sign. The reference angle is pi over 6. Okay, so that is equal to 1 over negative 1 over radical 3. So that is negative radical 3. How about cosecant 4 pi over 3? That's 1 over sine 4 pi over 3. That's quadrant 3. Quadrant 3, sine is negative. The reference angle is pi over 3. That is 1 over negative radical 3 over 2. That is negative 2 over radical 3. That is negative 2 radical 3 over 3. So if it is not in sine, cosine, tangent, make it in sine, cosine, tangent first. And then after that, you deal with the angles. If it is negative angle, bring the negative out. If sine, cosine, if sine and tangent for cosine, cosine negative is cosine positive, right? And so on and so forth. Now, this one is, what is cosine 3 pi over 2? That's 1 over, I mean secant 3 pi over 2, that's 1 over cosine 3 pi over 2. Okay, but cosine 3 pi over 2 is 0. So this is undefined. How do you know cosine 3 pi over 2 is 0, Thomas? That's the x component of 3 pi over 2 of the coordinates associated to 3 pi over 2. Okay, that's for number 9. Number 11, find the linear speed in meter per minute and angular speed in radian per minute of a wheel with radius 5 centimeters, travel 8,000 centimeters in 4 minutes. The radius is 5 centimeters. In meter, that is 0.05. The distance traveled is 8,000 centimeters. That is 80 meters. Okay, the time is 4 minutes. It's already in minutes, so we are fine. So what is the linear speed? The linear speed is distance over time. That's 80 meter over 4 minutes. That is equals to 16 meter per minute. How about the angular speed? Linear speed is equals to angular speed times radius. If this is 16, this is 0.5. So angular speed, omega, will be 16 over 0.5. That's 32 radian per minute. Before I do number 12, let me do number 13 first. A sector area of a circle with radius 6 centimeters. The sector area is 24 centimeters squared. Find the perimeter. I need to find the radius. I have the radius. I need to find the arc length, huh? So the area of a sector is equals to 1/2 S times R. Beside another formula we have, that the one I used earlier, is 1/2 theta R squared, right? Okay, there are two versions, one of them using theta, that's theta R, 1/2 theta R squared, the other one using arc length. So one of the theta times one of the radius give you the arc length, right? Arc length equals to theta R, right? Now, but this is what I will use, 24 equals to 1/2 S times 6. So that's 24 equals to 3S. So the arc length is equals to 8 centimeter. If the arc length is 8 centimeters, what is the perimeter? The perimeter is arc length plus twice the radius. Okay, so 8 plus 2 times 6, that's 20 centimeter. Okay, imagine this. This is the sector, right? Okay, this is the arc length. These are the radius. If the radius is 6 centimeters and the area is 24 centimeters squared, can we use that to first find the arc length? Now, after you get the arc length, don't forget that the perimeter still need to include twice the radius. Okay? That's for number 13. Go back to number 12. Secant x, secant theta equals to x. Theta is in quadrant 1. Oh, okay. It's in quadrant 1. That's really nice. So if secant theta equals to x, which is x over 1, it is in quadrant 1. So I can write it, depict that using a right triangle. If this is theta, secant is the reciprocal of cosine. This is x, this is 1. By Pythagorean theorem, this is square root of x squared minus 1. Right? So the sine x will be square root of x squared minus 1 over x. The cosine will be 1 over x. The tangent will be square root of x squared minus 1 over 1, which is square root of x squared minus 1 itself. How about cosecant? That's the reciprocal of sine, right? So that's x over square root of x squared minus 1. Let me rationalize that. That's x square root of x squared minus 1 over x squared minus 1. And finally, the cotangent will be 1 over tangent. That is square root of x squared minus 1 over x squared minus 1 to rationalize the denominator. Okay, I think that's the last question. Now, but let me modify question number 12. Suppose for number 12, variation. Suppose I say this, secant theta equals to x, but x is in quadrant 3. But x is in quadrant 3. Secant theta equals to x means 1 over cosine theta is 1 over x. Right? I'm sorry, 1 over cosine theta is x, therefore cosine theta is 1 over x. Now, in quadrant 3, cosine is negative. Is it right? Cosine is negative. That implies x is also negative. Now, in quadrant 3, cosine, let's say this is the theta, right? The coordinate here will be cosine x is 1 over x, right? Now, what is the y component? If this is 1. What is the y component if that's 1? So the y component plus the x component equals to 1. It's on the unit circle, right? So y squared equals to 1 minus 1 over x squared. Okay, so y is equals to the plus minus, but in quadrant 3, y is negative. So I use the negative branching of x squared minus 1 over x squared. Now, the thing is, remember x is negative, right? So square root of x squared when x is negative is negative x. square root of x squared is equals to absolute of x, which is x when x is greater or equals to 0, negative x when x is negative. So the y component will be square root of x squared minus 1 over x. Okay, now it seems like the y is positive here because there's no negative sign, but the negative already built into the x. Okay, the negative already built into the x. Now then from there you can do the sine, cosine, tangent, secant, cosecant, cotangent. Because all you need to do is to get the coordinates on the unit circle, right? Okay, that's how we will approach that. That's actually one way to approach that. Another way to approach that is you look at the reference angle. Yeah, another way to do that is actually looking at the reference angle. Okay, now that's for this one question here. This one test 419, test 3. That's a full solution. Let me rename it to just solution. Now we will go to spring 20. We did number 1, number 2. I think you can just do it yourself. This is a basic question. I really want to give a break already, but let me finish this one question and then I give a break. The central angle theta is 120 degrees, but it's not in radian. We need to make it in radian. That's 2 pi over 3. So the arc length S will be theta r, which is 2 pi over 3 times 5 inches. That's 10 pi over 3 inches. Therefore, the perimeter will be the arc length plus twice the radius. 10 pi over 3 plus 2 times 5. That is 10 pi over 3 plus 10 inches. The sector area, however, is 1/2 pi r squared. That's 1/2 theta r squared. 1/2 times 2 pi over 3 r squared. The 2 cancels, I get 25 pi over 3 squared inches. Am I too fast? We have a very similar question on this earlier, right? You know what? If I were you, if I were you and I have a teacher like Thomas who allow you to use cheat sheet and already went over all tests, I will print the solution of my all tests as my part of my notes. I should also have a cheat sheet, okay, which summarize all the theorem or all the properties that you need. Okay. Is that allowed? We get a question. For all my tests, it's open note, open book. For all my tests. That's for number 2. I'm done with number 2. 3 is done. 4 is done. Let's take a break. Together with your break, I would like you to do this number 5. See, this is the question we had similar earlier in 419. I give you a radius and the area. Okay, now use this formula, the area of the sector equals to 1/2 SR. We have another formula, theta r squared, right? But use this one to find the S. And then from there, you get the perimeter, which is the arc length plus twice the radius. Okay, now to find the central angle, you can go back using this. but get the theta. This is in radian, and then convert that to degrees. Okay, 5 minutes for this question number 5 plus 10 minutes break. We come back at 10:40. The perimeter, so the area is 32, 1/2 S times the radius R. So that's, I'm sorry, the radius is 5. So that's 64/5 equals to the arc length, which is 12.8. Happen to be a nice number. Is it right? Yeah, 12.8. So the perimeter will be 12.8 plus 2 times 5. That's 22.8 inches. How about the central angle? This is 32 equals to 1/2 theta times r squared. That's 64/25 equals to theta, but this is in radian, right? In degrees, that will be 64/25 times 180 degrees over pi. Okay, reduce by 5. Then I use my calculator. 64 times 36 divided by 5. That is 460.8 over pi degrees. You can actually also just do it this way. So keep it in fraction. So 64 times 38, that's 2,304 over 5 pi degrees. That's also okay. Yeah, no need to make it into decimals, like full decimal. You actually use the pi 3.1419 something something. No need, no need. Okay. We avoid rounding as much as possible. That's for number 5. Let's see. Number 6 is done. Number 7 is done. Number 8, a tire with radius 0.4. So R equals to 0.4 meter. With angular velocity 75 RPM. Now, RPM stands for revolution per minute. Okay, so this is 75 times 2 pi radian per minute. Okay, so the linear velocity phi will be omega times r, which is 150 pi radian per minute times 0.4 meter. So the unit here will be meter per minute. Okay, this will be 60 pi meter per minute. Now the thing is, how do we convert this to kilometer per hour? As a pre-calculus students, I do expect you to know how to deal with conversion. How to convert minute, I'm sorry, minute first. Yeah, how to convert minute to hours. To cancel the minutes, you multiply by 60 minutes, because the minute on the denominator, right? You multiply by 60 minutes over 1 hour. That will cancel the minute. You see what I mean? Okay, now to cancel the meter, okay, 1 kilometer is 1,000 meter, right? That will cancel the meter. Okay, so then when you multiply this, you will get 60 times 60, that's 3,600 pi over 1,000 kilometer per hour. That's 3.6 pi kilometers per hour. Okay, that's for number 5. Let's go on further. So this question is actually only a 2-point question originally. Originally just a 2-point question. 1 point for you to find the linear velocity. Okay. 1 point is to convert that into radian. Now the other 2 points is on the conversion. This 1 point here to convert to hour per hour and convert to kilometers. Okay, number, no number 7. Is it one number step? That's number 5. Oh, okay. I happen to have a bad numbering here. Number 8. AB is 10. Angle A is 60 degrees. AC is 15. Now, part A, find the exact value of AD. Find the exact value of AD. What connects AD with AB and 60 degrees? That's the cosine. So cosine 60 degrees equals to AD over 10. Okay, but cosine 60 degrees is 1/2. Okay, so AD is equals to 5. AD equals to 5. Let's see further. What is BD? BD is the sine part of that. So BD sine 60 degrees equals to BD over 10. But sine 60 degrees radical 3 over 2. Multiply both sides by 10. We get BD equals to 5 radical 2. Radical 3, I'm sorry. So how about CD? CD, AD plus CD, AD plus CD equals to AC. AD is 5, CD is what we are looking for, AC is 15. So CD equals to 10. Take a look on the graph. This is our CD. Okay. This is our AD. Okay, and then this is our CD. Now then, what is BC, I believe, the last question. BC is the Pythagorean application. Let me copy that situation down. We know this is 5 radical 3, and this is 10. So what is BC? BC squared equals to 5 radical 3 squared plus 10 squared. That's 25 times 3 plus 100. That's 175. So BC is the square root of 175. That's 25 times 7. Is it right? So BC is 5 square root of 7. Let me make it smaller. Hopefully we can see more relates to what we have seen so far. I hope this is not too small though. Okay. Yeah, so that you can see the picture by me showing you this way. Okay, let's see the next one. Y equals to 3 minus 4 of sine 3x plus pi over 2. Let me rewrite this as y equals to 3 minus 4. Sine, I will factor the 3 out. This is x plus pi over 6. Right, so the center is 3. The amplitude is 4. The range is center minus amplitude, center plus amplitude. -1 to 7. The period is 2 pi over 3. The phase shift is negative pi over 6. Now, how about the y-intercept? So y equals to 3 minus 4 sine pi over 2. Oh, but sine pi over 2 is 1, huh? So this is 3 minus 4, that's -1. So the y-intercept is 0, -1. Okay, the center is 3, the maximum is 7, minimum is -1. The phase shift is negative pi over 6 plus 2 pi over, so negative pi over 6 plus the period, 2 pi over 3, that's negative pi over 6 plus 4 pi over 6, that's 3 pi over 6, that's pi over 2. Okay, and then when I get the midpoint, you will see this is 3 pi over 6 plus negative pi over 6 divided by 2. That is 2 pi over 6 divided by 2. That's just pi over 6. The midpoint of negative and positive pi over 6 must be 0. Okay, and this will be, what is the midpoint of pi over 6 and pi over 2? Pi plus 3 pi over 12. So pi over 3. Now, instead of doing it mentally, which some of you can do, but if you have paper in front of you, just write it down. Okay, you don't want to do miscomputation for those the easy type of question. That's negative sign. So I start from the middle because that's sine. Negative because going down because negative. Those are the important coordinates. Then I curve it. Okay, that's for which question is this? This is for question number 9. Let's go on further. Number 10. You see, from fall 19, you don't see proofing, right? So in spring 19, you start seeing proofing. Now, let me remind you again, when you do proofing, I do require you to follow my procedure. What are those? That the first step, you need to show where you start, direction of your proof, where you start, and what that starting point looks like. For example, in this question, I think what I will do is I will start from the left-hand side. Okay, so the proof will be you start from left-hand side, right? The direction of proof, left to right. You can also do right to left if you think that's actually more convenient for you. Okay, the left-hand side looks like cotangent x minus tangent x over sine x times cosine x. Hold on. Did I do proofing yet for the other class? I somehow confused that with my West LA College class, which we did already. No, I didn't do proofing yet. I don't do proofing yet. So my bad. Let me know not doing proofing yet for now. Let me not doing proofing yet for now. We will do this on Wednesday. Okay, we'll do on Wednesday. So at least we finish fall 19. We'll do in the next meeting. That's your 6.1, by the way, which we will do tomorrow in your class. Okay, so we'll do tomorrow in your class. We'll have discussion on that. Of course, you can just watch the lecture video to see the procedure, right? Okay, but I will go over that in our discussion tomorrow. And then on Wednesday, we will do that. Come back here and do this again. Okay, this is section 6.1. This one is done. Oh, we are done with this section, this test. Okay, let's do 420 first. If I have extra time later on, if we can finish this 420 before the time's up, we still have like around 50 minutes. Then I will just go over the proof part. Okay, let's see, is there any problem we can do at this point here? Okay, let me ask you to do this on your own. Let me ask you to do this on your own. This should take you approximately, let's say, 7 minutes. Do you think that will be enough? Can I give you 7 minutes to do this, including the sketch of the graph? Let's say we come back at 11:05. 11:05, you're done with this. So then after that, after we go over that question, maybe in 5 minutes, then I will ask you to try number 6 again. Okay, another 7 minutes, let's say. Okay, and then I think we can do this one. This one is easy, not too hard. Yeah, we should be able to do that proofing. Yeah, let me ask you to do this first in approximately 7 minutes. Okay, let's start again. Center is -4, the amplitude is 2. The period is 2 pi over 3 pi. Oh, that's 2/3. If I factor the 3 pi out, then I get 1/3 here. So the phase shift will be, we shift 1/3 to the right. That's why it's positive. The range is the center minus the amplitude, the center plus the amplitude. That's -6 to -2. The y-intercept will be, you set the x equals to 0. But cosine -pi, just cosine pi. And cosine pi is -1. Right? Cosine pi is -1. the x component corresponds to angle pi. So that's -4 plus 2, that's -2. So the y-intercept is negative 0, -2. The center is -4, maximum is -2, minimum is -6. The phase shift is 1/3. The period is 2 pi over 3, so this is 1. 1/3 plus 2 pi over 3 equals to 1. Now the midpoint, 1/3 plus 1 is 4 pi over 3, divided by 2 is 2 pi over 3. This will be, what is this, pi over 2? When you add these two, oh, I'm sorry. Where did I get that pi? Sorry. Yeah, 4 over 3 divided by 2 is 2 over 3. 1/3 plus 2/3 is 3/3, divided by 2 is 3/6, that's 1/2. 1/3 plus 3/3, that's 5/3, divided by 2 is 5/6. And then that's -2 cosine, so we start from the bottom. Okay, so that's what the graph look like. In relation to secant, cosecant topics, suppose we have variations, or you can call that extensions. Suppose what we have is similar to that, but the reciprocal version. Secant of 3 pi x minus pi. Then what is the range? The range will be the complement of this. The range will be the complement of that. Everything but that except the endpoints. So it will be -∞ up to -6 union -2 to infinity. Okay, so that's for the range. Let's go on. Let's try this question. I give you 5 minutes. So right now it's 11:09. We come back at 11:14. Okay, try this, please. Okay, let's see. The center is -3. The amplitude is absolute of 4, which is 4. The period is 2 pi divided by coefficient of the angle is 3. Phase shift. By the way, to do phase shift, some people like to do it a slightly different way and it is still acceptable. What they did is they solved this for 0. So what they did is they have this 3x plus pi plus 2 pi equals to 0. Then when you solve that, you get x equals to -2 pi over 3. That's actually another way to do that. Okay, that's another way to do that. The range, I still prefer the first way. Yeah, it's easier to see from transformation point of view. Yeah, it's easier to see and understand from transformation point of view. Okay, of course, if you don't understand transformation, it's hard to do to start with, right? But this means you move pi over 3, 2 pi over 3 units to the left. The range will be center minus the amplitude, center plus the amplitude. That will be, sorry, I have extra comma here for no reason. That's -7 up to 1. The y-intercept will be -3 plus 4 sine 2 pi. But sine 2 pi is 0. So the y-intercept is 0, -3. Center -3. Up 4, that's 1, minus 4, that's -7. Phase shift -2 pi over 3. At 2 pi over 3, that's 0. Oh, this is -pi over 3. This is -pi over 2. This is -pi over 6. It's positive sign, so I add this. Okay, that's for number 6 here. Let's go on. Number 7, cotangent theta equals to x, and theta is in quadrant 1. So if I draw the right triangle in quadrant 1, right? Because it's in quadrant 1, then we can put it into a right triangle. Cotangent theta equals to x, so adjacent over opposite. Hypotenuse will be square root of x squared plus 1. So the sine will be 1 over square root of x squared plus 1. Rationalize. The cosine will be x over square root of x squared plus 1. Rationalize. The tangent is 1 over x. The cosecant is reciprocal of sine, that's square root of x squared plus 1. Secant is reciprocal of cosine, that's square root of x squared plus 1 over x. Now let me show you another variation and another technique. Variation. Suppose we change the cotangent theta equals to x, and x is in, let's say, quadrant 2. So in this case, x is negative, right? Because cotangent theta equals to x means tangent theta is 1 over x. Is it right? But in quadrant 2, tangent is negative, which means x itself already negative. Now imagine if I have x comma y here, the x already negative. Okay. So x squared plus y squared equals to 1, y squared equals to 1 minus x squared. The y is positive, right? So I use the square root without negative. That's the y. Hold on. Tangent is... I have two versions of x here. My x over y. Ooh, do I want to deal with that in... that's confusing. That's confusing. Let's do it another way. Yeah, because I have two x's right now, right? One is the x component and the other one is the x from this cotangent. Now, so instead of doing it that way, let's take a look on the reference angle. The reference angle, of course, then this would be 1 over negative x because x is negative, right? X is negative. If I use reference angle, x has to be positive. Now, then you go back to your right triangle. This is theta hat instead of theta. Okay, this is 1, this is negative x. This is square root of x squared plus 1. Okay, now then sine theta hat will be 1 over x square root of x squared plus 1. But in quadrant 2, sine is positive, and this is already positive. So sine theta will be just 1 over radical x squared plus 1. Of course, you rationalize the denominator. What happened with cosine theta hat? Cosine theta hat will be negative x over square root of x squared plus 1. But again, cosine theta hat, because it is a reference angle, it is positive, right? Is this expression positive? The answer is yes. Why? Because x is negative. X itself is negative. X itself is negative. With another negative, make it positive. So what is cosine theta without the reference angle? Cosine theta, when theta is in quadrant 2, should be negative. So I get x over square root of x squared plus 1. Tangent, cotangent already known, right? Tangent, cotangent already known. Now, how about secant, cosecant? Just do the reciprocal from here. Okay. Now, be very careful, however, when we have situation when the theta is, suppose I change the situation here. Let's say I say another variation of question. Let me do it on the right-hand side here. I will erase this later on. Okay, only those who watch the recording will see this. Another variation. Suppose I do cosine, I don't need to make it cotangent. Okay, so cosine theta equals to x, but the theta is in quadrant 4. Cosine theta equals to x, theta is in quadrant 4. So x is positive, right? That is positive. The x is positive. But what happened to the y? Y squared plus x squared equals to 1. If you want to see that from a unit circle point of view, y squared equals to 1 minus x squared, y equals to plus minus. But because it is in quadrant 4, then y should take the negative part. Okay, in other words, then sine theta will be y, cosine theta already known. The tangent theta basically use sine over cosine, so on and so forth. So the difference is we have two different approaches to answer this question. The first variation approach that from reference angle so that we can use a right triangle. But then later on, you need to shift back to the actual angle theta instead of reference angle theta hat. The second variation I did, I approached that from unit circle, not the same question though, but the second variation that I will show you here, the approach is still unit circle, okay, but pay attention to the quadrant, okay, pay attention to the quadrant. As I remember in the past, I did ask, so what happened was that I asked this kind of question in your test 3, right? Okay, where the theta is still quadrant 1. And in your final, suddenly I make the theta not in quadrant 1. I just need to ask that sometime, either in test 3 or either test 4 or the final. Okay, now what happened was that in the past, when I asked this in test 3 with quadrant 1, students tend to be fine, but then in the final, when I ask the same question, but I make it other quadrant, they screw up right away. Okay, so this is the type of question where my test question actually not the main question. My aim is actually this. This is my aim. This is where I'm going to ask sometime, either in the final or in your test 4. Okay, but a lot of students actually happy enough when they can get this and they never put a thought what happened if theta is in quadrant 2 or quadrant 3 or quadrant 4. Okay, now through this recording, I make you aware with that. Okay, so if you think about it like this though, if you think about this, the way I set up my teaching, okay, I start with lecture, which is already recorded. And then we have discussion, questions from the book. Okay, and then problems from all tests. That's how you get the informations. Now, how then I will test you? Different level also. Start from quizzes. The purpose of quizzes actually to prepare you for your tests. Okay. So beside preparing your tests for your tests using going over the old tests and through the discussion, the quiz is actually your hands-on experience that we can confirm before the test. I mean, a lot of you do suggested homework, I believe, right? But that's something I do not grade. So I do not know if you really do your suggested homework or not. Okay. But even in my test, it's actually to prepare you for your final. So I see my final as something really big. I see my final as something really big. I have past students who average 65%. Let's say your average is 65% at the end of the semester, which is a D. But your final happens to be very high, let's say 75. I passed this student. I passed these students, even though the average is not 65. Why? Because I believe this person finally catch up. Okay, but the one I see more often, and that's the reason I passed that students, that's because the one I see more often is actually the other way around. The average before the test was, let's say, 72, which is passing. But after the final is average 60, such that the average at the end is 65. If your average is 65 and your final is 60, which is below passing, then I don't have any reason to actually let you pass. Average point of view, that's a D. Your final point of view, that's an F. Right? But Thomas, what happened with my test? Well, that's why we do average, right? But when we look at the average, your average is 65. You are actually decreasing. You are actually doing from someone who are actually able, but then in your final, right before you go to supposed to go to your calculus 1, you are behind. So students in that situation, I have very hard time, but I did it anyway. I give that person a D. So that student have to repeat. On the other hand, students who have average 65, which supposed to be a D, let's say, okay, but because his or her final is passing, I just passed that student. Okay, call me unfair, but I know what I'm doing. Okay, because the main purpose is to prepare you for your final. That's the last step for us to see if you really prepared for your calculus class. Okay, of course, if your average at the end of the semester is like 50, even though your final is 75, it could be that your final is just happen to be that high, right? By one or another method. But I look up to final. Final is something very big for me. Okay, and when I give you my problems, include my discussion, all tests, quizzes, actual tests, that's all to aim for your final. And for the final is supposed to be a test that I can show to whoever your Calculus 1 teacher to show them what you have learned. And something you are proud to say that, hey, you know what? I passed this class with this kind of final. Okay, it should be, Precalculus is a class that should transform you from somebody who just know algebra to somebody who knows the inner work of that algebra. Okay, the details of that. Now let me erase this second variation here. So if somebody just look at the notes, it's not that I don't want to share with them. It's like I don't have enough space here. If I save it this way, then this page will become very, very small later on because of this extra extension here. No, I will not do this. Number 8, that's something we can do, right? Just use your calculator. This is 1 over sine 264 degrees. Using my calculator, make sure you control the mode. The mode has to be in radian. I mean, sorry, in this case, it's degrees. So 1 over sine 264 is negative 1.00551. And remember, 5 decimal places. Cotangent 45, that's 1 over tangent 45. That's in radian. Again, no degree sign. So change the mode into radian. Okay, 1 over tangent 45 radian, not 45 degrees. That is 0.61737. Again, that's 5 decimal places. Number 9. Suppose the theta is in degrees. This is in degrees. This is missing a degree sign. Okay. Use your calculator to find the theta such that cotangent theta equals to 7.92. Notice that the theta is in the first period. Okay, in the first period. In other words, you need to get the answer not only in quadrant 1, but also in the other quadrant. Now, cotangent theta is 7 point something. It means tangent theta equals to 1 over 7.92. Now, in quadrant 1, this will be tangent inverse of 1 over 7.92. Now, tangent is positive in quadrant 1 and also in quadrant 3. Now, the nice thing is they have the same reference angle. Actually, those two angles that we look for, not only for tangent, for secant, cosecant, sine, cosine also, they have different quadrants, but the reference angle has to be the same. Okay, so later on, once I get this theta 1, the angle in quadrant 1, let me change the mode first to degrees. Okay, so tangent inverse of 1 over 7.92. I get this is 7.19624 degrees. Now in quadrant 3, that will be that theta 1 plus 180 degrees. Do you see that? This is our theta 1. Okay, plus 180 degrees if you want to convert from quadrant 1 to quadrant 3. And that becomes 187.19624 degrees. Don't forget the degree sign. Okay, so there are two solutions for this. Find the theta in the first period from 0 degrees to 360 degrees. What happens if secant theta equals to 1.74? Then cosine theta is the reciprocal of that. And of course, theta is one of them is in quadrant 1. But the other one is in quadrant 4. Okay, again, they have the same reference angle. That is 54.92049 degrees. Now, the answer in quadrant 4 will be 360 minus that reference angle. 360 degrees minus that reference angle. So quadrant 4, that will be 305.07951 degrees. Okay, this is the theta 4. The same reference angle. That's for number 9. Let's go down further. Oh, we are done with this. Number 10. We are done with this number 10. Okay, with 15 minutes left, let me finish those 2 questions in proving, which you will see the discussion tomorrow, the more details. Okay, I write it here so that you can study in advance. Especially, this will be useful, especially if you already watched my lecture video. Okay, the first step, always start with the proof. The direction of the proof, here I'll start from left-hand side, going to the right-hand side. So I write left-hand side equals to the what you see on the left-hand side. Do not do any computation, simplification, whatever. No, nothing. Don't do anything. Don't do anything. Just write it as is. Okay, now follow the principle that we have done so far. The next step should be done in the next line. Okay, the next step is written in the next line. Second, another principle that we want to follow, if there are more than 2 trig functions, consider changing to sine cosine. Consider changing to sine cosine. Okay, that's the principle I will use. The second principle is not always true, but almost always true. Okay, unless you happen to see something that enables you to simplify that fast, but you do not want to deal with more than 2 trig functions at once. Okay, now because of that reason, then I will rewrite my cotangent as cosine x over sine x, and my tangent as sine x over cosine x. See, this is what I meant by if you see more than two trig functions, cotangent, tangent, sine, cosine, then rewrite it into sine, cosine. Now from here, then I multiply by the LCD. Multiply by the LCD, sine x cosine x, sine x cosine x. Let me move this a bit to the left. It's way too far to the right. Then I will get cosine squared x minus sine squared x over sine squared x cosine squared x. Now, the aim is to get cosecant squared minus secant squared. Now, notice that if I split this, this will give us the cosecant squared, and this will give us secant squared. If I split it, so let's split it first. Okay, I will split it. Cosine squared x over sine squared x cosine squared x minus sine squared x over, give me a second, sine squared x cosine squared x. Now, I hope you can see that this is, I cancel the cosine first. And then later on, I will write it as cosecant squared, right? Now that is our right-hand side. At the end of the proof, you box it. Box and shade it. Now, in old time, this shaded square was written QED. That's a Latin acronym of Quod erat demonstrandum, which means therefore it is shown. So in the past, they used QED. So if you read old textbook, then they use QED. Right now, we use that square. Now, the position of this square that we shade is approximately at the last line and cover the rightmost side. Okay, now I don't really hold this against you too much if you don't write that square at that position, but you need to write that square. Okay, you need to write that square. So if you write the square, for example, if you write the square here, let's say, I think I will be okay with that. Okay, I will be okay with that. But you need to write that square as at the end of your proof. And notice that not only our textbook, okay, your calculus textbook in future, you will also see this notation. You will have more and more proof, okay, and the end of the proof always use this notation. Okay, now let's review a little bit the procedure. The first line. Oops, what am I doing? Sorry. The first line. Direction of the proof. If you start from left-hand side, so you write LHS, stands for left-hand side, and whatever you see on the left-hand side. You will process this until you see the expression on the right-hand side. Okay, and write equals to right-hand side in the next line, and then box it. Okay, now in between here, do one step at a time. Okay, the question becomes like this: Thomas, what if something is so obvious for me, can I skip that step? If you ever have that question, can I skip this step, then don't skip. If you have that question, it means even your subconscious question if it is something so small that you can skip. Okay, my professor, my professor when I did my undergrad, also my graduate study, and also my PhD level, 3 different professors with no connection at all. With no connection at all. They don't know each other at all. Strangely, all 3 of them say exactly the same thing. All 3 of them say exactly the same thing. What is that? If you wonder, should I write that step or not, then write it. Okay? If you ever wonder if you need to write that step or not, then write it. Okay? I did my undergrad in Indonesia. I did my master's at Cal State LA. I did my PhD at USC. Okay, but all 3 professors says exactly the same thing. When it comes to proving, if you ever wonder, do I need to write that step, then write it. Okay, which means your subconscious itself already wonder if you need to write it. Now, it doesn't mean if you don't think you need to write it, then you don't need to write it. Okay. Okay. Now, it doesn't mean the other way around. The converse is not true. Okay, the converse is not true. Simply because you think you don't need to write it doesn't mean then you don't need to write it. Okay. In other words, if you wonder, do you need to write it? Okay, you better err on writing it instead. Okay. I still have 6 minutes for this. Let me finish this. Clearly on number 11, the left-hand side is more complicated than the right-hand side. Let me start from left to right. So I start from left-hand side. What it looks like is cosecant x times cosine x over tangent x plus cotangent x. Oh, we have cosecant, cosine, tangent, cotangent. Let's change it into sine, cosine then. So this is 1 over sine x times cosine x. This is sine x over cosine x plus cosine x over sine x. Complex fraction, so I will multiply by the LCD to clean it up. So the next step will look like, on the top, cosine squared x. At the bottom, I will have sine squared x plus cosine squared x. Oh, hold on. But the denominator is basically 1. Right? That's the right-hand side. We are done with the proof. Okay. Now that's for the solutions. Actually finished 3 tests today, right? Now on Wednesday, I will give you 1 new test that we will start from very beginning, but we will attack the trig part and the trigonometry part at the same time. Okay, basically in that 1 test. I somehow think I would like to share with you first that test and then try to work on that such that on Wednesday, if you have any specific question you want me to go over first, I can do so. Okay, or I can also do the work on that test from the very beginning. I will post that sample test. I think I will give you spring 18 one, the spring 19 one, or spring 18 one. Yeah, I will take a look. Okay. Oh, maybe yeah. That's right. From spring 19. I think I will give you spring 19 one if I have that from my old tests. Okay, that's for today. See you then on Wednesday.